Hello Professor, this is my presentation on assignment 3, predictive modeling and dashboard integration. So the objective of this assignment was to build a regression and classification model that predicts engagements on a social media data set, evaluate the model, create model visualizations, and export the enriched data set for Power BI visualization. So the data set I used for this analysis is a US open source elections X dataset which contains public expos concerning the 2024 United States elections. The analysis covers from October 17, 2024 through July 16, 2025. Here we have the source link where you can find the original dataset I used for the analysis. So I started off with importing the necessary libraries. I imported pandas and numpy for data preparation, skitlearn for modeling, and matplotlib and seaborn for the visualizations that we would see throughout the rest of this presentation. Next, I proceeded with uploading the dataset. So the original dataset contained over 97,696 rows and 28 columns. It included post text, dates, account information, sentiment, likes, reposts, replies, quotes, bookmarks, and impressions. I inspected the column names, data types, missing values, and duplicate records. There were no duplicate post IDs throughout the inspections. So next I followed up with cleaning and feature engineering. So for cleaning, I converted the dates and numerical columns to appropriate data types. Missing and engagement counts were replaced with 0 because they represented no recorded interaction. Missing text and account names were handled using appropriate replacement values. I also calculated the engagement as sum of likes, reposts, replies, quotes, bookmarks. Again, I also engineered content features such as word count, character count, hashtag count, mention count, sentiment, verification status, posting hour, day, month, and risk content indicators. I also created account history features using only posts published before each observation. This prevented future engagement information from leaking into modeling training. So next, we have the distribution and data split. So the engagement distribution was extremely right skewed. There were over 60,057 zero engagement posts, while a small number of viral posts received extremely high engagements. So for these, I trained the regression models using log of engagement plus 1. This reduced the influence of extreme posts and predictions were later converted back to the original engagement scale. I used a chronological 80-20 split rather than a random split. The first 78,158 posts were used for training and the final 19,520 posts were used for testing. So next, I developed 3 required regression models: linear regression, random forest, and gradient boosting. The models were evaluated using R-squared, mean absolute error, root mean squared error, and log scale R-squared. So this just shows how the models were being trained. So from this we can see random forest produce the strongest log scale R squared of 0.403, gradient boosting achieved 0.3818, and linear regression achieved 0.3360. Next, we head on to comparing the regression visualizations, and from this we can see that random forest outperforms linear regression and gradient boosting. We also have actual versus predicted engagement, and this was done using a scatter plot. Next was feature importance, which shows that an account's previous engagement was the strongest predictor. Character count, sentiment, word count, posting time, and mention count also contributed, with the least being the hashtag count. Next, I proceeded with the bubble scatter engagement visualization, and on here the bubble chart compares word count and engagement, color represents sentiment, and bubble size represents impressions. Next, I also developed the classification target model. So this random forest classifier was used to predict engagement level. Our engagement was defined as an engagement score greater than 1 based only on the training distribution. I proceeded with having a confusion matrix, and this shows over 11,739 correctly predicted typical engagement posts and 2,393 wrong predictions, and it shows 2,912 correctly predicted high engagement posts. So this indicates the useful predictive ability, although identifying a very high engagement post remains challenging. Next, I proceeded with training the selected models on all records and creating Power BI predictions. So I have the Power BI model metrics table, which will be exported, and I'll be using it for different matrices on my Power BI dashboard. And once that is done and completed, I'll be exporting the enriched data for Power BI. So this is the data which I'll be using in building the Power BI dashboard. The business insights and recommendations, I'll come back on here to explain them because these insights are gotten from the Power BI dashboard. So I'll be switching over to the Power BI dashboard right now so I can explain the charts and visualizations on there. So this is the Power BI dashboard I created, and it presents the predictive results created in the Python for the public exposed concerning the 2024 United States elections. After importing the necessary files I'll be needing for the Power BI dashboard, I proceeded to create the various DAX measures which I will be using for this dashboard, and some of which included total likes, total posts, total quotes, total replies, and what if forecast, negative posts, positive posts. So I'll just click on some of the dash measures so you can see its contents. Here we have forecast variance. Here we have high engagement post. Here we have mean absolute error. I'll go all the way down to total engagement and total likes and total quotes and total replies. Moving on to the dashboard now, we have KPI cards. We have over 4 KPI cards. The first one showing the actual engagement. We have over 1.65 million in actual engagements. predicted engagement, we have 510,000, and we also have a mean average error for random forest of 27.83 and a what if forecast of 561k approximately. So the what if forecast moves can be changed using the engagement growth toggle I have on here. So it just shows interactivity of the dashboard. So if I toggle this forward, we'll have the what if forecast moving. If I move it forward to 20%, it has moved from what it was to 613,000. We also have a date slicer that filters the post-level measures and time series charts. So for instance, if I click on the date and I'm about to filter for the month of October to, let's say, let me just do this. So we see every visual on here moves, showing the charts are quite interactive with the date. And also on the charts, they are quite interactive with one another. Here we have the monthly actual versus predicted engagement. Here we have a rolling 30-day average engagement. We have a regression model R-squared comparison. We have the top accounts share of engagement. We also have engagement interaction metrics. So like I said, the charts are all interactive with one another. If I click on here, it moves. All charts move. So overall, the dashboard integrates Python predictions with DAX-based business analysis. It shows that random forest is the strongest model for typical engagement patterns, but variables remain difficult to forecast. For that reason, organizations should combine model estimates with rolling performance monitoring, diversified account partnerships, and frequent model training. So I'll go back onto my Collab notebook to give you a summary of the business insights gotten from this dashboard. So from the analysis covered, the business insights and recommendations I would recommend that the actual engagement was much more higher than the predicted, showing that the variable content is difficult to forecast. Random forest was the best performing predictive model, but accuracy was affected by extreme engagement spikes. Likes, which were 69.7%, generated most engagement, making them the strongest indicator of content performances. Engagement peaked during specific periods in 2025, suggesting organizations should align campaigns with high activity periods. Top influencers contributed only 14% of the total engagement combined, so brands should work with multiple creators rather than relying only on one. A 10% growth scenario could add about 51,000 engagement, making the predictive models useful for planning and goal setting. So the overall conclusion demonstrates that machine learning predictions can help estimate engagement patterns, identify influential accounts, and evaluate campaign scenarios. Nevertheless, extreme viral activity creates considerable forecasting uncertainty. The most effective strategy is to combine random forest predictions with rolling engagement monitoring, interaction type analysis, and frequent model updates. Thank you.